Hello everyone. So today I'm gonna be talking about data representation. So this chapter is gonna be done in two parts of the video. So this is the first part. So the main objectives for today's video is going to be focusing on binary systems and hexadecimal. So they should recognize the use of binary numbers in computer systems and positive denary integers, conversion of binary and denary, and then there's the hexadecimal one, conversions, and we'll go over all this. So binary systems first. So binary is a base 2 number system which is made up of only ones and zeros, unlike denary, which is a base 10 number system made up of zeros, ones, twos, three, fours, up to 9. So binary system is used in computer systems like for storing numbers, text, images, sound, and programming instructions. So bit and bytes. A bit is a single 0 or 1. A nibble is 4 bits grouped together. A byte is 8 bits or 2 nibbles grouped together. So a kilobyte then is 1024 bytes. So many people think it's 1,000 bytes, but because binary is base 10, binary is base 2, so it can't be 1,000, it has to be 1024. So 1024 is like sort of the golden number we use in bits and bytes. So kilobyte is 1024 bytes, and then megabyte is 1024 kilobytes. But so then that would be 1024 times 1024 bytes. Then a gigabyte is 1024 megabytes or 1024 cubed bytes. Then there's a terabyte, which is equal to 1024 gigabytes. So that gives like how big terabyte or gigabyte is, right? 1024 to the power of 4 bytes. Yeah, that's the table which we use. So to convert binary to denary, there's basically two methods. So basically, a binary system is like the denary numerical system, whereas we have 10, we go up by powers of 10 in denary because it's base 10. Binary goes up by powers of 2 from right to left because it's base 2. So basically, to convert binary to denary, we just place it in this column, and then we add the values together. So for example, 10010011, that's a byte, the 8 bits grouped together, right? So that would be 1 is we start from the left and then we go to the right. So the most left is 128. So 128 plus 16 plus 2 plus 1, that's gonna be 147. That's how you convert binary to denary. Now, we need to know how to convert denary to binary. So we have to set up columns as we did before, and then we go from left. So if we have to convert something like 35 to binary, we have to see what is the largest value from the column that goes into it. So in 35's case, it's going to be 32. So if we use 32, what do we have left? So that would be 3, because 32, we have to add 3 to 32 to get 35, right? So now we would use the table and write it as the sum of 32 and 3, but 3 can be written as the sum of 2 and 1. So eventually 35, it can be written as the sum of 32, 2 and 1. So that would be 0 0 1 0 0 0 1 1. So application of binary. There are three main applications of binary. Number one being computer registers. They're very small. So basically, a register is a group of bits, and computer registers are small but very fast piece of memory which is used to carry out calculations. Digital displays. They have a register which is used to store and determine the state of each segment. So for this, in the case of this one, we can see that this is 1 2 3. They have been given numbers, and 1 means on and 0 means off. So wherever there's 1, the light shines, and then we can form numbers like that. So there's also registers in industry. So basically, registers can be used to hold a state of a machine, like robotic arms, etc. So now we have done binary. Now we can move on to hexadecimal. So hexadecimal is a base 16 number system. Uh, we have 10 numbers, so we can't express them. We cannot express 16, so we use alphabets as well. So we use 0 to 9, and then from there on, we use A to F. So it's closely related to the binary system, and it uses this conversion table. So up till 9, it has numerical values, and as it gets to 10, it has alphabetical values up till 15. It's very important for you to remember this, otherwise, because it's going to be used in multiple instances in throughout the course. Yeah, that's how hexadecimal looks like in computer. It's we learn to convert two digital hexadecimal system numbers as mentioned earlier. So we'll use the following conversion table. It'll be 16 and 1. Okay, because it's a base 16, it's obviously gonna be, so the first column from the right is gonna be 1, 16 to the power of 0, then 16, then 256, and then it goes on and on. So you need to know what to do when you have to convert hexadecimal to denary. So from you have to multiply the left hand digit by 16 and then add the units. So basically, in what it's talking about here is uh, for example, just take 2f in as an example. So we separated into 2 and f. So 2 is on the left side, so we multiply it by its place value of 16. So 2 times 16 plus, we multiply f. Remember, f is 15, so f by its place value of 1. So that's 15 plus 32, which is 47. Now denary to hexadecimal. So now, firstly, we have to divide the number by 16 to get the number of 16s, basically the place value on the left digit. And then the remainder gives us the value in the units place, basically the right digit. So if we have to convert 19 to hexadecimal, that would become 19 divided by 16 is 1, 1 point something. So we know that would take 1/16 in there, and then the remainder would be 3. So hexadecimal value is 1, 3. Remember, it's not 13, it's 1, 3. The second example is 47 to hexadecimal. So we know this 16 goes into 47 two times with a remainder of 15. So hexadecimal value is 2f. Converting binary to hexadecimal. So we separate the binary byte into two nibbles, and then we convert each nibble to denary and then hexadecimal. So let's take this byte into account. We separate it into two nibbles. Remember, nibble is a group of 4 bits, and then the first nibble 1101. It's 13 in denary and it's D in hexadecimal. And then 1001 is 9 in denary and 9 in hexadecimal as well. So the hexadecimal value of 11011001 is D9. So, now converting hexadecimal to binary. So split the two. It's the same method for that we used for converting binary to hexadecimal. We separate it into each hexadecimal character, and then we find the nibble of that, and then we combine both nibbles to form the byte. A byte. So 6C, if we have to convert 6C to binary, we separate into 6 and C. So 6 is 6 in denary and 0110 in binary. Remember, this is ones. That's twice. That's 4. That's 8. So 4 plus 2 is 6. And then C is 12 in denary um, and then it's 8420. So it's 8 plus 4. So 1100 in binary. So 6C is 01101100 in binary. So why do we use hexadecimal? We use hexadecimal because it's easier to read and write as compared to binary, and then so it's easier to convert to and from binary, which makes people have less errors. So the uses of hexadecimal. So the first use is colors in the hypertext markup language known as HTML. So color is defined by the amount of red, green, or blue. Remember, these are primary colors it contains. So blue would be 0000FF. Red would be FF0000. Green would be 00FF00 because the first two values are for red, then it's green, then it's blue in the form of RGB. Number two is um, MAC addressing. MAC addresses are used to identify internet enabled devices. So each PC mobile phone will have a unique MAC address, and it's uses hexadecimal. Then assembly and machine code. These are examples of low level languages. Low level languages are they're low, but it's actually harder. And high level languages such as um, hexadecimal is easier. So computer memory is machine code, or assembly code. So using hexadecimal, it makes it easier, faster, and less error prone to write code compared to binary. Lastly, debugging. If you need to examine what's wrong in a program by looking at its main memory, you can look at the binary value, such as that, or you can look at the hexadecimal value. And for sure, the hexadecimal value is easier, so you can spot the error and correct it easily. So memory dumps. Memory dumps are used as so basically hexadecimal is used when developing a new software or when trying to trace errors. Memory dump is when memory contents are output to a printer monitor. That's what a memory dump in a computer would look like.